I'm going to use this triangle with angles A, B and C and edges A, B and C to prove that the cosine rule, which is a squared equals b squared plus c squared minus 2bc cosine of a, is true. I've done a previous proof, a visual one, and I've linked to that in the description and the comment section if you'd like to see how that's done. The first thing I'm going to do is to divide this triangle into two smaller right angled triangles by drawing a line through the angle C that's perpendicular to the base. Because the line goes from the base to the top of the triangle, its length is the height of the triangle. The length of the original base was C, but we now have two triangles, so we have two bases. I'm going to call the base of the triangle on the left side C1 and the base of the triangle on the right hand side C2. These bases combined make up the original base, so obviously C1 plus C2 equals C. Now the first thing I'm going to do is to take the sine and cosine of the angle A, which is in the smaller of the two right angle triangles, and then I'll use that to express the height and base of the triangle. Notice that in the triangle the hypotenuse is B, the edge that's opposite to A is the height, and the edge that's adjacent to A is C2. So taking the sine and cosine of A, the sine of A is equal to the opposite, which is H, over the hypotenuse, and the hypotenuse is B, and the cosine of A is the edge that's adjacent to A, which is C2, over the hypotenuse, which is B. And now we can express the height and the base of this triangle by rearranging these equations. If you just multiply both sides of this equation by B, then the B on the right hand side of each equation cancels, and we get that the height equals B times sine of A, and C2, which is the base, equals B times cosine of A. Now notice that in the cosine rule we have the value of A squared given by this expression on the right hand side of the equation. But now that we have the base and height values for a right angled triangle, we can find an alternative expression for A squared. You'll know from Pythagoras' theorem that if you square the edges that are adjacent to the right angle and then you add the two squares, that will give you the value of the hypotenuse squared. So if we look at the right angled triangle that has the edge A, you'll notice that A is the hypotenuse. So then we could rewrite A squared as a sum of the other two sides squared, and that would give us that A squared equals C1 squared plus H squared, which are the base and height of the triangle that has a hypotenuse A. We now have the value of A squared given in two different ways, as C1 squared plus H squared, which we know must be true because this is just Pythagoras' theorem, and as the right hand side of the equation given as the cosine rule. Now if the cosine rule is true, then the right hand side of this equation does equal A squared. And so if the right hand side of both of these equations do equal A squared, then the right hand side of the two equations must be equal to each other, which means that C1 squared plus H squared must be equal to B squared plus C squared minus 2bc cosine of A. If we can show that, then the cosine rule must be true. The first thing we need to do is to translate the right hand side of Pythagoras' theorem using the trigonometric values we found earlier. But we don't have a trigonometric value for C1, we only have it for C2. But we can use the equation that gives the value of C and rewrite that to give the value of C1. So all we'd have to do is subtract C2 from each side, and the plus C2 and minus C2 cancel on the left hand side, so C1 equals C minus C2. So C1 squared must be equal to C minus C2 in brackets squared, and adding H squared to that gives us A squared. So if we multiply out the brackets, we get C squared minus 2 times C times C2 plus C2 squared, and H squared is added to that. Now we can translate the C2 and the C2 squared. So we get that all of this equals C squared minus 2C times, well, C2 is B times cosine of A. So that's B times cosine of A. And C2 squared must be B squared times cosine squared of A. So we add that. That's B squared times cosine squared of A. And we add H squared to that. And all of this equals A squared. The last bit to translate is the H squared. Now H equals b times sine of a. So h squared must equal b squared sine squared of a. And we add that to the rest of the expression, so let's just copy the expression down. We can now simplify this expression, but before doing so I want to rearrange it so it will make more sense once it's simplified. And another minor note, in the part of the expression that says minus 2cb times cosine of a, we can swap the c and b around because it's a multiplication. It won't make a difference to the value. Now notice that the first two parts of the expression are actually multiples of b squared, so we can factor out the b squared, and that will give us b squared equals sine squared a plus cosine squared a. And we can copy the rest of the expression. Now we're almost finished, but there's one more thing that we can change, and that's what's inside the brackets multiplied by b squared, sine squared of a plus cosine squared of a. Now if you've watched my most recent video, you should recognize this as part of the Pythagorean identity. This identity states that sine squared of an angle plus cosine squared of an angle is equal to 1. If you want to see why that is true, I've linked the video in the description and the comment section. What this means is that the value inside of the bracket sine squared a plus cosine squared a equals 1. So b squared times the brackets is just b squared times 1, which equals b squared. So the result is just b squared. And we can just add the rest of the expression. And so what was initially given as c1 squared plus h squared is actually b squared plus c squared minus 2bc cosine of a. So the right hand side of the equation that we got from Pythagoras is equal to the right hand side of the cosine rule. And we said that if that was true, then the cosine rule must be true. This whole calculation is just a translation of a squared, which must be equal to b squared plus c squared minus 2bc cosine of a. And there is your proof for the cosine rule. That's it for now. Thanks for watching.